Hey all, it's Jason. Welcome to the 4th of July edition of Sweatpants Science. No, I'm not wearing sweatpants. It's too hot. Plus, it's the 4th of July edition. That would just be ludicrous. Anyhow, today I've got a topic, an experiment that is going to be fun. Hopefully you'll learn a little bit and enjoy the experiment, and maybe, just maybe, we might find out if there's a way to beat the DUI Intox 9000 Draeger, the breathalyzer machine. The topic is actually a spin-off from the last topic regarding light absorption, reflection, or transmission. Today we're actually going to focus on light absorption. And I'm also going to go into a little bit about how scientists and engineers use electronics to make measurements. So we're going to see how we accomplish that and see how this applies to when we're using electronic devices to measure, for today's purpose, alcoholic vapor. And we're going to see if we can predict the alcohol content of an unknown alcohol. Before we get to all that, though, it's dinner time. So I'll see you afterwards. All right, I'm back. Oh, that was delicious. Pork chops on the grill. Can't beat it. So anyhow, this is the lab. Today is the laboratory. I want to show you the experiment, run through the experiment, show you how the intoxilizer works. Because believe it or not, I actually set up my own intoxilizer. When you're breathing into this machine, your air with that ethanol vapor goes down the tube into a chamber. Inside that chamber is a tungsten filament. That tungsten, when it illuminates, emits infrared light. Well, that infrared light shoots down through the chamber, through your breath and the ethanol content that's in it. That alcohol absorbs the infrared light. So the wheel that's turning with the filters on it is actually checking, and it's looking for these different percentages. You can think of this as almost like a signature, like your own signature when you write it out. No one else signs the same way you do. Well, this is the signature of ethanol, and that's what the machine is looking for. So let's skip to the experiment here. So here I have 3 glasses of different alcohols, and they have different alcohol concentrations. You know the rule, if it says 90 proof, divide by 2, and that's what you get is 45% alcohol by volume. During the experiment, I will set one of the shot glasses inside the chamber, and the air will draw the vapor up. And I'm going to measure the voltage difference. And this is how scientists and engineers make their measurements, because not all the time can you whip out the old ruler and measure, that's 90 proof or 45% alcohol by volume. Sometimes it's not an analog device that you can use to measure. So how do we make measurements of luminosity? How do we make measurements of transmissibility or absorptivity? or even strain and stress within material, well, we use electronic devices and we measure the changes in voltages. And this is how we determine the level. So in this experiment, I'm going to look at the voltage when each of these shot glasses are in the chamber. And what will happen is that vapor gets pulled up into the chambers and it will block or absorb a certain amount of infrared light. And the voltage is going to change. And then I'm going to do that for all three shot glasses. Now I know the alcohol contents for all three of them. But what I'm going to do, the goal of this experiment, is to estimate the alcohol content of the banana liqueur. So real quick, just so you know, we have golden grain, which is that's 95% alcohol by volume. And then we also have silver rum. And in this silver rum, we're right at about 40% alcohol by volume, or 80 proof. So I'm not going to tell you what this one is until after the experiment, but I want to show you how this works, and I also want to check and verify that I'm actually measuring correctly, because I don't want to give you bad info. So we're going to measure this banana liqueur and see if we come up with the right number. So let's jump into the experiment real quick. Alright, so there you have it. There's the experiment. I went through. What I like to do is I like to give several runs, try to get the best averages possible. Just so you know, golden grain's 95% alcohol by volume, or 190 proof. That's the rum. The silver rum, well, that is 40% alcohol by volume, or 80 proof. And the banana liqueur, actually 99 proof, which makes that 49.5% alcohol by volume. And looking at the results, I wound up getting 50.4. So I'm a little off, but surprisingly, this little deal, it worked great. So let me tell you, here's the secret. I'm going to tell you how to beat the Intoxilyzer, the Draeger unit. All right, this is a surefire method. But just keep this in mind. If I can build a simple unit here that can measure the alcohol content of these samples and actually get an unknown sample, get that relatively close. All done here in my house. What are the chances you think you're really going to beat that machine? So here's how you beat it. Rideshare. This weekend, any weekend, if you plan to drink, rideshare, call a cab, call a friend. I want to make sure everyone makes it home safely, because the last thing I want you to do is think about my experiment as you're sitting in front of that machine having to blow in front of the trooper or the police officer. So everyone, happy 4th of July. Be safe, and we'll see you next time.